that they're going to be different from this. So we have to use sigma of population. Does that make sense? Yeah, and n is 25. Is this not? No, standard deviation is. Sorry. So if we solve for z, and their mean score was 105, so we know x is 105. over the square root of 25. So z equals -1, right? So this is our test statistic. And what is the value of p? Okay, so p, the value of p associated with 0.1 is 0.1587, but our hypothesis is two-sided. And this only gives us one side, right? Yeah. So what do we have to do?
Double it?
0.3. Yeah. 0.315. That makes sense.
It doesn't matter if I get a score of negative or either negative or positive.
You just have to remember that you want the tail.
Okay.
So if you do the negative, if you do the positive, you're going to have to do 1 minus. Otherwise, you'd get 0.84-ish. Okay. Can we move on? A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis on the standard treatment is 2 years. In an early trial, she tries the new treatment on 4 subjects who have an average survival time after diagnosis of 4 years. Although the survival time has doubled, the results are not statistically significant, even at the 0.15 significance level. What is the best explanation? Why? So we got to vote for C. Anyone agree? So our choices are A, a placebo effect is present, which limits statistical significance. Do we have any evidence for that? No. The sample size is too small to determine if the observed increase cannot be reasonably attributed to chance. Could this be possibly our answer? Maybe our power is too small, right? So maybe B, okay. Although the survival time has doubled, the actual increase is only 2 years. I don't know. I think extra 2 years is pretty good, right?
Yeah, it's excellent for cancer.
So if in the real world, if you are increasing someone's survival by 2 years, as long as their quality of life is good, that's a good thing, right? So potentially we want to explore more about this. So probably not C. So, and then D, the calculation was an error. The increase of 2 years is very significant. Well, let's assume the math was right and the calculation is correct, and she didn't reach significance at 0.15. It's probably B. If she redid the experiment with a larger sample size, she's probably likely to find significance.
Who does experiment with 4 people?
We have to start somewhere, especially with rare diseases, right? So a lot of rare disease studies are done on a case study basis, right?
But so you don't have results. You don't have like significant.
In public health is different in medicine in that way. In public health, we want big sample sizes and using communities. But in medicine, sometimes the disorders are just too rare to collect a big sample, so you do have to sometimes make decisions based on just a few examples. So it's possible that someone has a sample size of 4 or 10, something small, but it
medical modeling
could still be statistically valid, because there will be methods, especially if you continue to multivariate, where you can do things to manipulate your 4 subjects so that you can come up with some significance. So 37, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis on the standard treatment is 2 years. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4 years. Although the survival time has doubled, the results are not statistically significant, even at the 0.15 significance level. Suppose, in fact, that the new treatment does increase the mean survival time in the population of all patients with this particular type of cancer. Which of the following statements is true? A type 1 error has been committed, a type 2 error has been committed, or no error has committed? So first, let's decide if an error has been committed. It has, right? Because she didn't come to the right conclusion. Now, what type of error was made?
2.
Type 2 error. Why?
The alternative is true, but
You failed to reject the null, right? So type 2. Failed to reject, but this is true. Which means, what's a type 1 error?
You reject the null, but it's actually true.
Which kind of error would you rather make? In your research, which kind of error would you prefer?
2?
Yeah, right? Because what if we come to the conclusion that a treatment works, but it doesn't? That's more dangerous than deciding that it doesn't work and it does.
Well, unless you don't do the treatment then, and then your patient dies, and you find out later it would have worked. I guess they're both bad.
They're both bad. They're both bad. But we can help this from happening.
Mm-hmm. Right.
There are things we can do. We can increase our power, make sure that we have the right sample size. So if we have everything going for us, and we still we did. Sorry. We rejected. No, sorry. This was right.
I know the best way how to help that.
How?
Increase the significance level.
Well, okay. People have argued for that, and in psychology, 0.1 is acceptable. Like in certain fields, they have increased the
Make it
significance level.
0.3 and everything will be fine.
0.3. I don't know. Would you put your money on
Yeah,
you're getting a medication, but there's only a 70% chance that it's going to work? I don't know if I would take that chance.
there's no other way.
Yeah. Okay, so let's move on. We're almost done in the home stretch. 38 and 39. A researcher plans to conduct a test of hypothesis at the 5% significance level. She designs her study to have a power of 0.85 at a particular alternative value of the parameter of interest. What is the probability that the researcher will commit a type 1 error? A, right? that make sense?
She didn't answer. Oh, yeah, because it's 5%, right?
Right.
So it's,
So there's a 5% chance that you rejected the null, but it was true, right? This makes sense to everybody? Okay. What is the probability that the researcher will commit a type 2 error for the particular alternative value of the parameter in which he computed the power?
0.95.
Well, what is power?
25 or 0.15?
Power equals, they said it was 0.85. And if type 2 has to do with alpha, and type 1 has to do with alpha, and type 2 has to do with beta, we have to know that 1 minus beta equals power. And we need to know beta, right? Beta is the probability that the type 2 error will occur. So if we solve for beta, 1 minus beta equals 0.85. So 1 minus 0.85 equals beta. Beta equals 0.15. So the probability that the researcher will commit a type 2 error is 0.15. So, any other questions before we end the review session?
Thank you so much.
You're welcome.
thank you, question.
I will be likely on campus all weekend if you guys are here
You have session tomorrow or
studying.
no?
I will not have a session, any more sessions this weekend. I'll address all questions individually by email. I will be here, likely in my office tomorrow, Saturday, Sunday. I'll be here all weekend working on my exams. So if anyone has a question, you can email me. I'll likely be checking it every few hours. And
So from what time to what time?
good question. I would say Saturday from noon to 6, Sunday from noon till midnight,
Fantastic.
and tomorrow probably from 11 till 10. I'll be here late.
You need some rest.
Are you gonna upload this to?
Yeah, but it's like from 27. So
That's okay.
that makes
We've
sense.
recorded the other ones.
So who will upload the other one?
Kelly's. It's Kelly's cell phone. So if you want to hit stop on the